So for our first graph, y equals sine 2x, if we think about that 2, that's going to be a horizontal compression by a half. The period of sine is normally 2 pi. And now that we have a 2 in there and we're compressing it by a half, the period is now going to be pi. You might also remember that the other day we developed a formula for sine and cos, that our period was always 2 pi over b. And there was a formula for tan. For tan, the period is always pi over b. So now our b value is 2. So if we plug in 2 where the b is and simplify, you're going to find out that your period is pi. Your amplitude is always the number out in front. It's your a value. And since there's no number written in front of sine, it's like there's a 1 there. So our amplitude is 1. The domain of the sine function is everything. So we can write xer. And if we're looking at this graph right now, if we were going to graph this quickly, we would start by saying, well, it goes up to 1 and down to -1. Its period is pi. And I divide that into 4 equal sections. So half of pi is pi over 2. Half of pi over 2 is pi over 4. This will make this 3 pi over 4. And a sine graph starts in the middle going up, back to the middle, down to our minimum, and so on. And this is what this graph looks like. Its range goes from the maximum to the minimum. It'll go from -1 to 1. The phase shift, it hasn't been moved left or right at all. Now, when we get to the zeros, we look at our graph and we see that we've got 0. We'd have pi over 2. We have pi, then 3 pi over 2. Same thing in the negative direction. And if we just start listing them all, and that's what I've got here first, you've got 0. Then you got pi over 2 and negative pi over 2. You'd have pi and negative pi. You'd have 3 pi over 2 and negative 3 pi over 2, and so on and so on. Now, this is just a list. How do we write this mathematically to write them all? Well, one of the techniques that we saw before when we did our zeros for cos and when we did our zeros for tan and sine is you can take one of them. So let's look at this. There's a first one. We have one at 0. How far is it before I get to my next one? What's the distance in between them? Is that distance always the same? That distance is always the same. And how far is it from one to the next? It's always, you can either add pi over 2, or if you went backwards, you could subtract pi over 2. So the way that we could write all of our zeros looks as follows. Start with one that you know. I'll start with 0. And then you could add or subtract pi over 2 as many times as you want, as long as k is an integer. You wouldn't have to have the 0 plus, right? It's just showing. So on an answer key, that probably wouldn't be over there, and it would just be pi over 2 times k. But that gives you the idea. Start with one that you know, and then find out how much you have to add or subtract to go in between them. And then we get them all. So now if we look at the second one, for the second one here, we've now added a half in front. What's that going to do? That's going to be a vertical compression by a half. It's going to change our amplitude from being 1 to being a half. Luckily, I can quickly graph that by just changing these to a half. And my graph is perfect. We still have a period of pi. But now our range goes from -1/2 to a half. What about our zeros? Have they changed? They're exactly the same place that they are. So again, you would write it as pi over 2 times k, where k is an integer. So this works for both of those. And again, if you can find that general way of writing it, it's a lot easier than listing them all like they've done there. So in our third one, now we're adding a shift. We're adding a shift of pi over 4 to the right. So as far as writing this down, I would probably add the word right in there because that's the way that it's shifted. Pi over 4 to the right. Our period is still going to be pi because your period is always 2 pi divided by your b value. Amplitude is still a half. The range still goes from -1/2 to 1/2. But now what's happening is everything in our graph, if I go back to my graph here, all of these points are getting shifted pi over 4 to the right. So this point will get shifted there. This maximum gets shifted pi over 4. Everything gets shifted pi over 4 to the right. And this is our new graph. So can you see that our zeros have now changed? Everything's been shifted pi over 4 to the right. And if we look at them, you have pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So when we go to write our zeros, again, you might want to start by listing them all like they've done there. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, and so on. But when I go to write them all out, I could start with one that I know. I know that I have pi over 4. The distance in between them is still pi over 2. So I would start with the one that I know, and then I could add or subtract pi over 2 as many times as I wanted, where k is an integer. So that's using the same idea that we wrote all our zeros from last time. Some of you might say, I noticed that they're all odd numbers times by pi over 4. And maybe you remember how to write odd numbers times pi over 4, because we did that with cosine. What did we put in the brackets to make it an odd number? Remember? This makes it even. Add 1, and you make it odd. So you could choose either way. I really like recognizing this is pi over 4 is one of the ones you have, and then figuring out the distance in between them. I think that's a nice, easy way of doing it. But if you like the odd-numbered one, you could use that as well. And finally, the last one here. Now we're shifting things down 3. So we have pi over 4 to the right. We're also shifting things down 3. When you shift things down 3, it's going to change your center line. So if I was graphing this quickly off to the side, 1, 2, 3, my center line is now down here at y equals -3. With my amplitude being a half, that means that I'm going to go from my center line up a half and down a half. So up a half will get us to -2.5. Down a half will get us to -3.5. Those will be our new minimums and our new maximums. They wrote it with fractions, but you could have written it with decimals, or you could have written it -2.5. You could have written it in interval notation. That would be fine as well. And now if that's my maximum and that's my minimum, and my cos graph or my sine graph is going to be in between there, what are our x-intercepts going to be? There's not going to be any.